Hello, my name is Libby Barnes. I am the chair of the AIA Monterey Bay Coat Committee, and today we're excited to present to you a webinar called Lumber Reimagined, the Future of Reclamation. This webinar will qualify for one learning unit, and your credits will be submitted to AIA. We'll have questions and answers following the presentation. Here are our learning objectives. The presentation is being recorded, and we will post both the PDF of the slide deck and recording on our AIA Monterey Bay website under the COAT channel. Urban Machine, a company based in Oakland, California, is leveraging the latest robotics and AI for salvaging lumber waste so it can be used to build again at a price competitive to virgin lumber. This approach not only creates local economic opportunities and shortens lumber supply chains, but also reduces embodied carbon and alleviates pressure on forests. This webinar will address how this technology is changing the way waste lumber is handled, opening new opportunities for designers to specify deconstruction and reclaimed wood. The talk will also cover the AIA Materials Pledge component on circular economy, showing how disassembly and reuse aspires to a zero waste goal for construction activities. This year we started out the series on the AIA Materials Pledge, what you can do now to address all 5 tenets of the pledge. So our first talk was about the Materials Pledge itself, and then we had a seminar, a live seminar at Granite Rock to address climate health, discussing low carbon concrete solutions. Today, we're going to address circular economy. I encourage you to all go to the pledge starter guide, which will be posted in the chat. Like I said, this presentation will be shared on the AIA Monterey Bay website, and as well as the recording. Circular economy. So the Ellen MacArthur Foundation, which is a nonprofit that is promoting circular economies, lays out 3 principles for circularity: eliminating waste and pollution, circulating products and materials at their highest value, and regenerating nature. The building sector, as it is structured today, remains largely intractable on all 3 principles. Construction and demolition debris amount for about 30% of all waste produced globally. It is estimated that 75% of all the waste still has some residual usefulness. This suggests 2 avenues of opportunities for the building industry: innovate in the decommissioning process, removing assemblies or systems in ways that leave them intact for other immediate applications. The second is to build more horizontal integrations with other sectors so we can become part of their circular loops of materials and they become part of ours. I'm now going to turn over the presentation to Ashley Yanda of Urban Machine.
Hey, I'm going to share my screen here. Libby, let me know if that is visible and in full screen.
Looks great.
Awesome. Well, thank you very much for the introduction, and hello to everyone on the call today. I'm very excited to be here to talk about the future of wood reclamation and to explain the mission that we're on here at Urban Machine. I'm the Senior Manager of Business Development, and we're going to talk a little bit today about what we're doing, as well as using reclaimed wood in your projects. As Libby had mentioned at the top today, Urban Machine is a robotics company based here in the Bay Area. And our mission is to build a sustainable future by reclaiming wood from construction waste and turn that into premium lumber products. Our founders, who have combined backgrounds in robotics, construction, AI, they created this nail pulling robot after identifying the huge amount of wood that ends up in our landfills each year, in large part due to the metal. So the nails, the screws, and the metal fasteners. Currently, that gets removed by hand, which is labor intensive and time consuming. This, of course, drives up the cost, which means that instead of reusing the wood, it's being incinerated, turned to mulch, or sent to the landfills. And we are here to change that. So concrete and steel currently, and let me just change my view here. So concrete and steel both have recycled paths. They're not ending up in the landfills, but the wood is. And it happens to be one of the largest contributors to landfill waste here in the United States. So this is something that really needs to be solved for. It's estimated that the landfills are going to be full in approximately 60 years. The EPA says that about 37 million tons of dimensional lumber are heading to our landfills and incinerators every year here in the United States. And to put that number into perspective, the 37 million tons, that is about half of what we're logging annually. So the number is huge. Also, lumber is among one of the most predominant building materials for our housing stock. And as we've all seen over the past few years, wood hit some really dramatic highs, which had a big impact on affordability across the market. So having the ability to utilize reclaimed lumber at scale can really be a game changer economically. So we're here to, as Libby said, try to make things more circular. We're able to do this by utilizing our robot to take this wood from construction and demolition and put it back out there so that it gets another life. The wood that's been standing in these old buildings grew in real forests, of course. It's been there for 40 to 100 years. It's hard, straight material that can be reused for architectural applications as well as structural use. One of the major upsides from an aesthetic perspective too is that a lot of this wood, so think old growth redwood, for instance, is it's no longer coming down. So it's this beautiful, tightly grained material that's unmatched, and it's really stunning. So as I mentioned previously, dimensional lumber from C&D waste is currently either landfilled, burned, crushed for mulch, or reclaimed and kept in its dimensional form, all of which factor into sequestration. When the wood is disposed of in a landfill, it often decomposes faster than indoors due to the fungi and insects. And when wood breaks down, carbon dioxide is not the only greenhouse gas released back into the atmosphere. Methane, which is 25 times more potent than carbon dioxide, is also present, making it a much more immediate global warming effect. When wood is burned, it's no longer carbon storage, of course, and you also increase carbon dioxide concentrations in the atmosphere, actually by more than if you had used fossil fuels, and thereby contribute to climate change. When wood is ground into mulch, the mulch will continue to store carbon, which is good, but not for as long as reclaimed wood because of the smaller size. Wood mulch also tends to decompose faster than solid wood. So that brings us to the final method, our preferable method, of course, which is to reclaim the wood and keep that in its dimensional form. It's suitable for reuse. It can be put right back into a new project. And of course, the reclaimed wood gets to keep its carbon storage role. So moving from the problem now to the solution, I'd like to take a look at our nail pulling robot. So I'm going to go ahead and play this video. and just kind of chat through what's happening. It's a drone video that was taken out at All Bay Lumber Company in American Canyon, where we had about a 2-month pilot project this past fall. So you'll see the drone zooming around some of the lumber stacks that we have out there, and then the machine in action. Oh, and I'll turn this down so you can hear me. So the machine is 80 feet long. When it's all assembled, it's modular, so it can be transported on 2 40-foot trailers. The wood starts at brushing systems, which polishes, the metal, making it easier for the cameras to see. That lets the AI technology know where it is. So then the flashing that you see comes from the cameras looking for that material, learning what kind of metal it is. And then it directs the bird beak pickers working on all 4 sides of the wood at the same time. It then finally goes through a metal detector to be sure the wood is clean and metal free. We do process 2 main types of wood, both solid timber as well as glulam, from 2x4s all the way up to 6x18s. And our core scope is really just getting that metal out. So once the wood is metal free, back into the wood supply chain it goes, and you can use it in your projects. The next slide. So right now we have 1 robot working full-time as our central pilot program. We'll be wrapping that up this 2 weeks from now. So we're currently deployed out at Green Waste Zanker Resource and Recovery Center, which is in San Jose. It happens to be one of the largest construction and debris recycling plants in the entire country. So we're there pulling out the high quality dimensional lumber from the tipping floor in order to denail it and then send it back into the wood economy for reuse. So our goal ultimately is to have machines operating in 10 additional metropolitan areas within the next year, and then scale up significantly in the next few years, both nationally and internationally. We feel it's important that we have these machines available in multiple locations so that the full cycle stays within an intended 100 to 200 mile radius. So for instance, a building is deconstructed in the Bay Area, it's then denailed in the Bay Area, and it's reused in the Bay Area. In contrast with virgin lumber, which travels on average thousands of miles. So the hope would be for it to stay in a regional location. And then, as I mentioned, it is mobile. So if it's a Bay Area machine, it could, for instance, be deployed to Zanker, where it is now, for a couple of months. It could then go to a job site for a few weeks, a large commercial job site that may be coming down, and then back to another waste facility in the area. But the goal would be to keep the machine within that same region, and then all of that material coming in and going out is in that same general location. So designers, what can you do as designers? There's a couple of things that I'd like to touch on, but the first is specifying deconstruction. So this is it's not the typical way of doing things, but we think that it's integral in as part of our mission, because the material that comes out obviously needs to be treated as though it's going to be reused in its dimensional form. So it's a little bit more meticulous than what currently happens with the material being, torn down and crushed essentially. So as I mentioned, it's, currently the demo contractors right now take an excavator more or less and smash the building. The reason being is that the only financial incentive they have is to minimize costs. So they're breaking it up into small pieces to minimize the trucks to the landfills, minimize the tipping fees they're paying at the landfills. And we want to change the economics here by bringing down the cost to denail and clean up this material so that it can then go back into the supply chain. So then it can switch from being a cost to contractors to a potential revenue source. And that's, something that we're working to do right now. While we're in our research and development phase, we're iterating on the technology, but we're also proving that there's an economic model for reclaimed lumber, and that the value is actually higher than the value of using it for mulch or burning it for fuel. So the specs here are a huge component. That's ultimately what the contractors are going to follow, of course. So having these early conversations with the owner operators and decision makers and getting that into the design plan before the building even comes down is very important. And we've included a couple of QR codes here with some general deconstruction specifications that you can access and utilize to start doing this right away. The next ask for you as designers is to specify reclaimed material as your preferred type of wood. So our goal as a technology provider is to bring that cost down, as I mentioned, for reclaiming the lumber so that it can compete with gin. This way you can have a locally sourced material from right here in the Bay Area or wherever you're located, which is a huge win on the sustainability front. It's not going into a landfill, so there's no train bringing it in, no trucks bringing it in from the Pacific Northwest. Your trucking is minimal, so you're using a high quality, and you're also using a high quality product in your buildings. The other thing to note is that the lumber itself can be regraded, so you can reuse it for structural purposes as well, and it takes a lot less energy to reclaim than to deconstruct. Excuse me. And we can talk, we might get into this in questions and answers, but currently in Washington and Oregon, wood that comes out of a building, so that was used for structural purposes, can be reused automatically structurally. So assuming that you have access to the as-built original information, and that wood was rated as A2 or better in Oregon and Washington, you can automatically put that into a new building. The reason being that wood actually gets harder and stronger over time. So a wood that was good enough to go in the building 30 years ago is actually going to be stronger material now. That's not the case in California. It's not an automatic, you don't have the automatic ability to put that into a new building. You do need to have that structurally regraded, but that's, a step obviously that can be taken. So it can be used in many different applications, structurally being one of them. Again, just it needs to be regraded right now in California. But we are working with, several folks to try to update our codes similar to that of Washington and Oregon, because that's kind of a great hurdle to kind of take down and make it more accessible. And finally, to wrap up and along those same lines, I wanted to touch base here on a great application for reuse in projects. This is dowel laminated timber, or DLT. So we're currently working with some of the folks in the forestry department at UC Berkeley, designing our own panels utilizing reclaimed material. There's no glue and there's no nails. It's just lumber. So for us, we think it's the ultimate circular story. This could be used for flooring, wall partitions, panels, roofing. And DLT can be utilized in everything, of course, from small TIs and build outs to large ground up projects. This is currently being utilized in other countries, although it's not typically being used with reclaimed lumber, and it's not being produced at scale in the US right now, which is what we'd like to see as we continue to move our technology forward. So that concludes my portion. This is our QR code to our website. Of course, feel free to reach out to me. Thank you so much for listening to our presentation. I'll hand it back over to Libby. And of course, I'm here for questions and answers.
That's great, Ashley. Thanks so much for your presentation. I really appreciate those of you that have joined our webinar. And so we're going to open this up to to Q&A, and then I'll also share my final slides here with some information on those. So I'm going to let Selena Brown, who's on our COAT committee, help speak on the questions.
Thanks, Libby. We just wanted to open it up for questions. I can read them off in the chat, or you can ask them directly to Ashley. If anybody has any questions.
There's 2 in the Q&A. You want to read those off, the 2 in the Q&A?
You know what? I don't see them here.
Oh, okay. All right, I'll read them off. Rob Nicely asks, do you track the moisture content? And if so, what is it typically?
I'm sorry, could you say that one more time, Libby?
Yeah. Do you track the moisture content? And if so, what is it typically?
So we are, we're not currently tracking the moisture content. It is varying quite a bit because we're pulling material from different locations. So depending on where it comes from and what species it is, how old it is, of course, that's going to vary quite a bit. Typically, it's very, very low moisture content for the most part. We're processing really just clean dimensional lumber. So we're not working with anything that, of course, has mold or anything like that. We do have some interesting material that we're starting to test that's coming out of Pescadero. So it's right there on the coast. And that does have actually a higher moisture content than a lot of the other material that we've worked with so far. But more to come on that as we continue to grow, especially outside of Northern California. Obviously, every region has its the predominant type, like we see Doug fir here most of the time. And as we grow and move into other regions, we'll start to see differences there as well.
Great. Another question, do you have a source for DLT?
So we are we're utilizing the material that we're cleaning. So a lot of the material that we receive is coming to us free from demo contractors who are, as I had mentioned before, they want to avoid the trucking and the tipping fees. So we take that material essentially off their hands, and then we clean it. We then have material to sell. And one of the things that we're working with is creating these DLT panels internally. So we're working with UC Berkeley on the engineering side of things. And then we're actually working with All Bay Lumber Company, which is where you saw the drone footage, to manufacture those panels. And those panels will be available sometime in Q1 coming out of American Canyon, which is near Napa.
And if we wanted to purchase just the lumber itself that's already been pulled?
Yes, you could. So that can be, right now we have, the lumber that's purely, we have bundles of lumber that's just been denailed, and it's ready for its next life, whatever that might be. And then we also will be setting aside a certain amount of material that will be used for the DLT panels. So we'll have a little bit of raw material as well as the finished panels themselves. Okay,
so contact Urban Machine to get more information on that. Great. And I'm going to post your email up in a second.
Wonderful.
Another question is, do you sort by species and dimension?
Yes. So typically, right now everything's kind of sorted by, it's more sorted by size, but it kind of falls into species automatically because a lot of, for instance, if we take a load from a job site that came out, it's a bunch of beams and it's a whole ceiling, it's all going to be really the same type of material and similar dimensions, where we have to take a little bit more time to sort species and dimension is when we're pulling from the recycling facilities, because we're pulling off a mixed tipping floor. So there's a lot of different sizes and lengths and dimensions in there. But yes, that's what we're attempting to do and kind of keep control over that, just so that we can monitor the inventory that's coming through. And then also sell it in, bundles when larger amounts of material are.
Okay, that's great. Sorry, there's a little noise in the background. What is your distribution method and how do you purchase this material?
So right now we, as I mentioned, we're just, we have a single machine operating just here in Northern California. So right now we're really selling the material on a case-by-case basis. So we're working with architects, with contractors, owner operators to kind of work again case-by-case basis on the material we have and what the project looks like. And then we kind of, we're selling it directly from Urban Machine. We are not going to be in the wood business always. We will, as we continue to iterate the technology and expand operations, eventually we'll just be leasing the machine. And so this, kind of these early days were, as I had mentioned in the presentation, we're proving this revenue source. So we're selling the wood, kind of showing how it can be done, showing the amount of material that can be cleaned, so that folks who are interested in selling that material. So let's say a reclaimed housing manufacturer or a furniture maker, that they might utilize that machine so that ultimately they're the ones that are selling the material.
Okay, those are the questions from Q&A. If anyone wants to pop on and ask a question, go right ahead. I'll leave it open for another second, and then we can go to the last slide. Okay. I think this is a great start to this discussion. Employing a kind of circular economy in our practice is a really big lift, but we need to change the way we specify and detail and build. Today, I heard the phrase screws, not glue, thinking about how can we disassemble our buildings easier. And I encourage all of you to check out these resources online to learn more about circular economy. Also, I put in a link. This AIA California provides a what you can do now, not just on circular economy, but on all types of ways to decarbonize our practice and become more resilient through our design work. So that's here on the on this webpage. And then I've been listening to a series called Metropolis Magazine Deep Green Podcast, and the link is here, and we can post it in the chat. And then the Ellen MacArthur Foundation, which I mentioned at the beginning of the presentation, their focus is on circular economy. So there's a lot more information out there, and I'm really glad that Urban Machine is basically in our neighborhood, and that you are not only finding ways to reuse lumber, but also thinking about decarbonizing and lowering fuel costs by keeping it local. If there's anything else that anyone wants to share with us, please jump in. Otherwise, we're done with the presentation.
Thank you, everyone. And thank you, Libby. I appreciate it.
Yeah. And thank you all for coming.
Thank you.
Great. Okay. Well, I'm giving everyone a half hour back to their lunchtime. So like I said, we will post this on the AIA Monterey Bay website in the coming weeks, and have a happy holidays.